Hello everyone, our today's topic is square root of any complex number. I will show you two different ways to find the square root. The first one is a formula. I will deduce a formula. Using this formula, you can easily calculate the square root of any complex number. And the second one, I will show you a technique. Just by observing any complex number, you can calculate the square root. So let's start with first one, using the formula. Suppose z equal to say a plus ib. This one is your complex number, and we have to calculate square root of z, that is root over of a plus ib. Suppose its square root say x plus iy. So we have to find the value of x and y. So if you square both sides, that is a plus ib equal to x plus iy whole square, and what it will become x square plus I square y square plus 2y xy. Now I square means minus 1, so you can write a plus ib means x square minus y square plus I into 2xy. Now compare the real and the imaginary part. That is, this one the real part, so this will equal with this, and this one is the imaginary part, this will equal with this. So what you can write, that is x square minus y square equal to a. This one is your first equation, and 2xy equal to say b. This one is your second equation. Now using these two equations, we have to find out the value of x and y. Now see what we will do here. First of all, we find the value of x square plus y square. So we take the square. You know its formula, a plus b whole square, that is a minus b whole square plus 4ab. So what is the value of this one? Is a square. And what is this one? This one is b square. So x square plus y square upon whole square equal to a square plus b square. Then what we will get here? That is x square plus y square equal to root over of a square plus b square. Just taking square root on both sides. Now what is this one? That is root over of a square plus b square. This one is the modulus of z. So this one is your number 3 equation. Now simply you just got x square plus y square equal to mod z and x square minus y square equal to a. So by elimination method, you can easily calculate the value of x and y. So if you add 1 and 3 by 1 plus 3, what you will get? Y square will be cancelled. 2x square equal to mod z plus a. That is x equal to plus minus mod z plus a by 2 its root. And if you subtract them, that is subtract 3 minus 1, then what you will get? This minus this. So 2y square equal to mod z minus a, and from this you can write y equal to plus minus root over mod z minus a by 2. So see what is the value of x and y, that is root over of a plus ib equal to, if you write this one, plus minus root over mod z plus a by 2 plus minus I root over of mod z minus a by 2. Now From this plus minus sign, you can take the combination. So here you will get 4 combination, but I will take only 2 combination here. This will become plus minus root over of mod z plus a by 2 plus I into root over of mod z minus a by 2 if b is greater than 0. That is, if the given complex number, this part is plus, then your result here will also plus. That is, if the imaginary part is positive, then the result here also will be positive. And if this b is negative, root over of a plus ib equal to plus minus of root over of mod z plus a by 2 minus I into root over of mod z minus a by 2 if b is less than 0. So I just remove this one. So these two is our formula, root over of a plus ib. If the given complex number, if the imaginary part is positive, then use this formula, that is, take plus sign here. And if the imaginary part is negative, that is, here will be the negative sign, then you take the minus sign here. So using this formula, you can easily calculate any square root of any complex number. So I suppose I will give you an example. How can we use this formula to calculate the square root of any complex number? Say one number is, say, z equal to 2 plus 3i. This one is a, say, complex number, and we have to calculate its square root, mod z, root z. So what is its value? This one is mod z plus a by 2 its root. Now as this one plus, so take here plus sign, mod z minus a by 2 its root. So this one is our formula, take here plus minus sign. Now what is mod z? Mod z means root over of a square plus b square, 4 plus 9. 4 plus 9 means root 13. So what will be the value? I think take here 4, then you will get a standard good result. So this one will be 16, then this one will be 25, and you will get, say, 5. So what will be the value here? Here 5 plus 4 by 2 its root plus, sorry, here I will be appear, I root over of 5 minus 4 by 2. So result is 5 plus 4 9, 9 by 2, that is 3 by root 2 plus I into this one 5 minus 4 means 1 by root 2. You can take common as 1 by root 2. So what you will get? 1 by root 2, 3 plus I. That one is our answer. So without any thinking, if you use this formula, you will get your required result. I just apply another problem. Say z equal to only I. So you can write this complex number in this form, 0 plus I into 1. Now you have to calculate mod z. So what will be the value? Mod z plus a by 2 its root. You take plus sign here because this one is plus, that imaginary part is plus sign. I into mod z minus a by 2 its root. Take here plus minus sign. So what will be the value? Mod z means mod z means root over of 0 plus 1, that is 1. So your value is 1, a means 0 by 2 its root plus I into 1 minus 0 by 2 its root. And what is the value? 1 by root 2 plus I into 1 by root 2. You can take 1 by root 2 as common and you get the result 1 plus I. Now take another example. Suppose z equal to 1 minus I. So what is root z? Mod z plus a by 2 its root minus. I will take a minus sign because here imaginary part is negative, b is negative. Root z minus a by 2 its root and take plus minus sign. Now what is mod z? Mod z is root over 1 plus 1, that is root 2. So what will be the value? Root 2 plus 1 by 2 square root minus, here also I, this one root 2 minus 1 by 2 its square root. So you can take 1 by root 2 as common. So required result is root over of root 2 plus 1 minus I into root over of root 2 minus 1. So this one is your required answer. So if you use this formula without any thinking, you can get the standard or required result. Here I will also explain you another technique where without using this formula, just observing you can calculate square root of any complex number. Now how can we do these types of technique? Suppose z equal to say a plus ib. Our target is to making the square root of this number. Now our target making this number a perfect square number, that is I will convert this complex number into a perfect square. This may be minus. Suppose say I take only plus sign. So if you break this one, what you will get? X square minus y square, this is the real part, plus I into 2xy, this was the imaginary part. That is, if we want to convert this complex number into a perfect square number, then this I part, that is the imaginary part, here is the part 2xy, because this part will be equal to 2xy. So 2xy term lies in the imaginary part where I lies, and this part contains this part, x square minus y square. Real part contains this part. That is our target, making this complex number to a perfect square. Now how do we think? We think our 2ab term is content in this imaginary part, and square term, that is x square minus y square, is content in our real part. Suppose I am doing an example. How can we think this problem? Suppose this 7 minus 24i, this one is your complex number. So first of all, we will check whether there is any 2 in the imaginary part. Obviously there is a 2 in the imaginary part. So you can write this one, 7 minus 2 into 12i. So this one is your xi, only xy. So you have to break this 12i in such a way that square subtract difference of the square is will be 7. So how can you break this 12? You have to 12 means you can write 3 into 4. 3 4 are 12. Now check the difference of the square. Suppose 3 3 are 9 minus 4 4 are 16. 9 minus 16 means minus 7. So if you take 4 square minus 3 square, this one is 7. So you can write this 7 in this way. So I write here 7 means 16 minus 9 minus 2 into 12i. So 16 means 4 square. I can write this 9 as plus 3i whole square minus 2 into 4 into 3i. You see, you get the proper structure a square plus b square minus 2ab. So, what is this one? This one 4 minus 3y whole square. So, I convert this complex number into a perfect square number. So, now you will get easily the answer, that is root over of 7 minus 24i equal to plus minus 4 minus 3i. This one is your answer. Another problem I am doing. Suppose the z equal to 16 plus 30i. First of all, you check whether they are in the imaginary part, if 2 is involved here. Obviously, here 2 is involved. So, write this complex number in this way, 2 into 15i. Now, break this 15 in such a way that difference of their squares is 16. How can we break them? 15 means 3 into 5. Now, see, 5 square means 25, 3 square means 9. 25 minus 9 equal to 16. So, I can write this 16, 25 minus 9 plus 2 into 59. Now, make them structure, that is 5 square. I can write this 9 as plus 3i whole square plus 2 into 5 into 3i. So, you can see this one a square plus b square plus 2ab, that is 5 plus 3i whole square. So, root over of 16 plus 30i equal to plus minus 5 plus 3i. So, just observing, we just convert this complex number into a perfect square number. Then you can easily make it square root. For the last one, if I take say only minus I. So, what you can write here, this one 0 minus I. So, first of all, see, this one is your 2ab term and this one is your a square minus b square term, but here 2 is not present. I can take any fractional number. So, first of all, I adjust here 2. How can you adjust? Just multiply half, that is 0 minus 2i. In this way, we adjust this 2. Now, we have to break this 2 into 1 into I. Now, we have to break this 1 in such a way that their difference square of the square should be 0. So, you can write only 1 minus 1, because 1 can be broken in the way 1 into 1. So, how can we write this one? First one 1 square, second one I square minus 2 into 1 into I. Now, see, a square plus b square minus 2ab. So, what is the result? 1 minus I whole square. So, root over of minus I equal to plus minus 1 by root 2 1 minus I. So, you see, in this way, by converting the complex number a perfect square just through observation, you can easily calculate the square root of a complex number. But better if you remember the formula root z plus a by 2 root over and plus minus I into root z minus a by 2, then obviously without thinking we can get the required result. So, thank you for today.